Hey guys, what's up? I hope you all are doing well. So in this video again I have come back with a new problem, and this time I have taken a problem, the problem related to concept of binary tree. Okay, so you can see the problem name is binary tree right side view. Okay, and this is quite a famous problem. It was asked by some of the company tags, right? Paytm, Walmart, and Ola cabs. So it was a famous problem that was multiple times asked by many company interviews. Okay, so let's not much waste time and get into the problem. Okay, so right, binary tree right side view. Given problem is telling that given the root of a binary tree, fine. Imagine yourself you are standing on the right side of it. Return the values of the nodes you can see order from top to bottom. Fine. Okay, they are telling that hey, you have given a binary tree. Okay, and suppose you are standing at the right side of the binary tree and you have to tell them that hey, these are the nodes that are visible to me. Okay, and you have to print those nodes in the output section. Okay, see, this is a tree and this one is root of this tree, and two is left subtree, and three is right subtree. Again, 5 is children of 2 and 4 is children of 3, and these are the leaf nodes 5 and 4. Suppose you are standing at the right of this tree. Right side means this side, right? This side. Okay, from right side if you see the tree you can see 1 is visible. Okay, 3 is visible and 4 is also visible, but see, 2 is not visible. Why? Because 2 is behind 3. Okay, you cannot see something that is behind 3, right? Because you are standing at the right side, so 2 will be not visible. Similarly, 4 is visible but 5 is not visible. Why? Because see, if you are standing at the right you can see only 4 but you cannot see 5 because 4 is hiding 5. 4 is hiding 5. 5 is behind 4, right? So that's why 5 will be also not visible. So you have to print the output from top to bottom. Okay, so top it is coming 1, you can see 1. 3 is middle, you can see 3, and 4 at the bottom, 4 you can also see, right? So output will be 1 3 4. See, output will be 1 3 4. Fine, let's go to the next example. See, 1 null 3. 1 null 3 means like what? If you create a tree, okay, with 1 null 3, 1 will be the root, left side subtree will be null, and right subtree will be 3. See, this you can think 1 here and 2, for these two it will be null, and for this 3 it will be 3, right? So it will be a subtree. It will be tree, right? Binary tree. So if you again see from right side, you can see only 1 and 3, right? So that's why asking they are printing 1 3, right? So that will be the output. See, now this is the example 3, and in example 3 root is null. See, no nodes are there, so this will be the base case. Means whenever there is root is null, you have to return the null. Okay, fine. So this is the problem given. Now I'll tell you that I'll explain you that how we can implement this solution, right? And at the end I'll show you the code also, that how we can print this 1 3 4. Okay, so I'll show the I'll tell you the explanation now, right? Let's start. Okay, so see, I have taken that example that was given in the lead code portal. Okay, I have taken this example. Now I will explain you that how this tree is working. Okay, and how we are getting this output as 1 3 4. Correct. See, see, basically this tree. Okay, what I can use is we can use of level order traversal. Okay, see, basically what happens in level order traversal? What happens? See, in level order traversal, we go to each level. Okay, we go to each level and we print the nodes, right? See, the first level, 1 is there. In the second level, in the second level, 2 is and 3 is there. In the third level, 5 and 4 is there. One thing, can you notice that the last element of each level is our output? Can you think once? See, this is the first level, right? In first level, only one element is there. So there is no last and first, only one element is there. We so then what do? We remove that. We keep it in the output section. This output section one. See, in the second level, 2 3 is there. What I told you, that remove the last element and keep it in the output section. What is the last element? 3. This 3 is the last element, right, of this level. So take this 3 and put it in the output section. 1, 3. Again, in the third level, what is the element is there? Last element, I'm telling you, last element. What is there? 4. Remove that element and put it in the output section. Then, if you see, the output will be 1, 3, and 4. See, this 1, 3, and 4 will be my output. Why? Because I'm going level by level of this tree and I am printing the last element of each level. 1 is the element, that is last element. Second level, 3 is the last element. And third level, 4 is the last element. So I'm just printing those and I'm getting my output. Right? It is very easy. Okay. So now I will tell you that, hey, how can I use a data structure that is called queue? Okay. And I can solve the problem. I can solve the problem how I can use the queue data structure, and I will tell you that how we can get the output. Okay. See, basically what I am doing here, this is a queue data structure. This is a queue data structure. Okay, I'm using here queue data structure. Fine. I'll tell you how I can use the code here that is given here and how I can get the output. Correct. So fine, as I told you the logic, like how we'll be using level order traversal, and as I told you the explanation, as I explained you how basically approach we are going to follow. Now I am going to take you to the code editor basically, and I am going to solve there the code, and I am going to write the code. And while writing the code, I will explain you each line of the code, how basically it is working, and how basically you are going to get the final output as 134. Okay, so let's go to the code editor and write the code, and let's see what we get the output as. Okay, so let's start. So fine, I have come to the coding section now, and let's write the code and let's understand the code what basically the code is doing. Okay, so while writing the code I will explain also. So uh, so keep your eye on the code. Okay, so let's write. Okay, fine. So basically see, this is a list integer. Okay, list. So I have to return a list. Okay, so I have to create a list before for that. List integer list. No, I'm keep creating an array list. Okay, I'm creating an array list. Then after that, what I'm doing, as I told that I'll be using queue data structure, so I'm creating a queue of tree node. Why tree node? Because I have to add the nodes to my queue. Okay, the tree nodes. Okay, queue equal to new linked list. See why I'm creating a linked list type of queue, because it will help us to make the links, because a tree will have links, right? Left side, right side links. So that's why I'm using a linked list queue. Okay, fine. Then I will add the root element into the queue. Okay, because I have to traverse from that element, right, to other nodes. So that's why I'm adding the root. Okay, then then I'll what I'll do, I'll traverse my root, traverse my what, my queue, while queue dot is empty. What I'm doing here, that till queue doesn't become empty, re- uh, queue doesn't become empty, we have to traverse with the queue. Okay, okay, got it. Then I am taking a new variable in the length equal to queue dot size. It will give me the size of this queue. Okay, then after this after this what I have to do, okay, after this what I have to do, I will take a for loop. Okay, and I will traverse the loop till my queue's size, queue's length. Okay, till my length. Okay, now what I will do here, I will uh, create it, I'll make it do a tree node temp equal to queue dot poll. What I am doing here is I'm what I have added in the tree, I'm pulling that. Means I'm removing that, then I'm picking that element, okay, and I will do operations, some operations with that node. See, as one was added, right? One was the root element, so it has now one here. It has now one present here. Okay, now I'll tell you what like basically program I'm going to write to do some operations with the queue. I'm doing that. Hey, if my I equal to len minus 1, then list dot add this temp dot val. What it is doing that if my I is now 0, right? Len minus 1. See, initially my length was how much? 1, because only one element there. Okay, so len minus 1 means 1, 0. So 0 equal to 0. It is matching. So if it is matching, then list dot add temp dot val. Temp dot val means what? This one was there, right? So in my list was there. It will here one will be added. Only have added. Okay. Now then see this t node was removed. Okay, this one was removed. Okay, this from this queue. Okay, in this queue one was there, now it is removed. One was there, now it is removed. Okay, so my queue is again null, again doesn't have any value. Okay, then I have to check if if temp not equal to, sorry, temp dot left not equal to null, then add queue to my queue that value temp dot left. Okay, similarly I have to do for the right side. If my temp dot right not equal to null, then add that to my queue, queue dot add temp dot right. Okay, it will be added to my queue. Okay, now my for loop, yes, okay, it will be added to my temp dot right. See, one was there. Okay, I removed that, then I'm checking that one was temp, right? This temp was right, so I'm checking that, hey, does one have left node? If it is having, add that to my queue. So my now queue, one was there right before, as I remove, two will be there now. Now again I'm checking for one right side. Hey, if my one is having three right side any element, it has, okay, it has, add that to my queue. Okay, now my queue is having 2 3. Again I will go to my while loop, first length. Again it will do the other iterations. Okay, again it will see the size. Now size become 2. Why 2? Because it is having 2 3. Two elements are there, so it has become 2. Again it will traverse from 0 to length, 0 to 2. Okay, 0 to 2, 2 means 0 1. Okay, again it will tree dot temp you dot pull. Now while pulling, it will pick 2 because the element that was there, 2 first element. Okay, so now it will check I equal to length minus 1. What is my length? 2. What is my I? 0. So 2 minus 1, 0 equal to 1, 1. It is not possible, so it will not add this 2 value. Then it will go to this section of the code. See, it will temp dot left null. See, 2 dot left, it is not there, don't add. Then it will check temp dot right not equal to null. Okay, yes, it is not equal to null, so add that to my temp dot right. Okay, queue to my queue, so 5 will be added here. After 3, 5 will be added here. Okay, and as I told that this 2 will be deleted, because see here I deleted no this queue dot poll. Okay, then again this for loop will check for 1 0, it was 0, right? Then it will go plus plus, it will make 1. Okay, then again it will come here. If 1 equal to len minus 1, len was how much? 2. 2 minus 1. So if 1 equal to 1, it is true. 1 equal to 1, it is true. So then list dot add temp dot val, which will be added? Can you tell me? This 3 will be added. Why? Because this was recently removed from this code. From this temp dot, because 2 was removed before that, now 3 is removed. So list dot add temp dot val. So 3 dot val means 3 will be added. So my list will have 1. This will my list, right? 1 3. Now list will have 1 3. See, I am getting the output. See, according to the output, I should get 1 3 4. I already got 1 3. Now I have to get only 4. Okay. See, now I have to again check. If temp dot left 3, does 3 have left value? No, 3 doesn't have any left value. So don't add to my queue. If temp dot right equal not equal to null. Does temp, my temp has right value? This 3 has right value? Yes, it is having. Add that. Which value is added? I have to add 3 dot right. What is that? 4. Add that to 4. Okay, now, and this 3 will be deleted. As I told, recently I deleted, right? Q dot poll means it will be deleted, right? So it is deleted now from my queue. So my queue is having 5 4 now. 5 and 4. Again I am going. Again I have to go this line number 25. Again, like because queue is not empty, right? It is still having elements. Again it will check queue length. It is having two element. Okay, it is having two element. Fine. Again it will check I equal to 0. Again, okay, now it will q dot poll. Which will be pulled? 5 will be pulled now. 5 will be pulled now. See, now my queue is having only one element. That is 4. That is 4. Okay, 5 will be removed. Now it is checking. I equal to ln minus 1. Ln minus 1 means how much? 1. And I is what? 0. It will initially it will be 0, right? So 0 is 0 equal to 1? It is not. So don't add this 5 to my list. So check if temp dot left. Does 5 have any left value? No. Does 5 have any right value? No, because it is leaf node. So don't add anything to my queue. Okay. Again my for loop will continue iterating 0 to 1 I plus plus. Okay, it will become 1. Okay. Now it will again pull from 5 it will pull 4. It will pull 4. Okay, because 4 was there only queue. Now queue my is empty. My queue is empty. See, now it is checking for 4. Okay. So I equal to n minus 1. What is length? 2. And I become now 1. So 1 equal to 1. It is possible. It is right. So list dot add temp dot val. Okay. So what will be added in my now? Temp. See, recently my temp became 4. So add that temp dot val. 4 dot val means what? 4. See, my list became 134. I am getting the output now. 134. I have to get 134. See, 134 I have to get. So my list has 134. Got it? Then it will go to next iteration, next section. If temp dot left, does 4 have any left value? It is not. It is leaf node. Then temp dot right not equal to null. Does 4 have any right value? It is not. It is not there. So don't add anything. Now my queue become empty. See, this queue become empty. So nothing is there. So now the code will not run this while loop. Okay, it is stopped now. The code is stopped now. List, I mean the while loop will stop now. Okay, now I have to return my list. My list. Okay, I have to return my list. Then I'll see that my program is running or not. Before that, I'll just do some cross check, some syntax error is not there or not. I guess you have understood the coding explanation as I like while coding I have solved and I have told you also that how basically we are getting. Okay, see now. Okay, I'll just check the code is correct or not. Okay, let's run the code. I guess it's correct. Yes, you can see guys, the code is perfectly working and we have got our final output, that is 134 output, expected output, and this output is same. Okay, I'll just yes, it's correct, it's correct. Okay, debugger, no, I don't have to check that. I'm just think, uh, taking another test case basically for cross check. Yes, it is true. Yes, it's perfectly working. And so let's submit the code and see if all the test cases are passing. Yes, all the test cases passed and our code is accepted. So that is all about the problem. I hope that whatever I have taught in this program, this code, and it has helped you to understand the program better. Okay, and also I have solved the problem, and I have solved like I've told you the how you can see the approach of this code, and that I have told you before only. So I guess I have uh, like hope you have understood the problem statement basically and understood the code also basically what it is doing and how we are getting the output. So that's all about the code. And And one more thing, the code will have the time complexity of order of n, because we are just going through the all the nodes of this tree, right? And it will have space complexity of order of n, because we are taking a queue data structure here, right, for returning our output. So it will be order of n complexity for the time, for the space. Okay, so that's all about the code, guys. Uh, so thank you for watching this video. I hope we'll meet in the next video. So till that time, stay happy and stay healthy. Okay, so bye bye, guys.